Coming back to mixtures. We're interested in not having mixtures, but actually in separating them into pure substances. And this is what the mining industry does. We get different minerals out of the earth, and they're usually mixtures, and we have to separate them. So there are different types of mixtures and different methods of separating them. Here are a few simple ones, and we are actually going to look at some video clips on how to separate them. How would you separate beans from sand if, for example, they fell in the sand? Well, the first and most simple way of separating things is to sort them. If they have different size or shape or color, that's quite easy. Sand and water, well, you could filter it. A liquid would go through and the sand would stay behind. Salt and water, well, you could evaporate the water. Sulfur and iron filings, well, we use a property of the iron that's different from the sulfur. And this is magnetic and this is not. And we're going to look at these in a moment. Water and alcohol are two liquids that dissolve in each other, and we would have to distill the alcohol to separate it from the water. Finally, we're going to show you how a separating funnel works to separate liquids that do not mix. We say they are immiscible. Let's go and look at some video clips now. Here we have a mixture of sand and beans. So I've spilt my beans. Now, how am I going to separate them? This is what we call a heterogeneous mixture. It's very easy to see the different components. And yes, I could pull them out one at a time, but it's a little tedious. But when you separate things like this, you can usually see a difference in shape, size, or color. And maybe it's just easier to separate it according to size. So a sieve is a very simple example of a way of separating according to size, and something that you would do in the kitchen. Now, that was a lot more efficient than trying to pull it out one at a time with a tweezer. Imagine being at the beach, and we've got a whole bunch of sand here. And say you're having a picnic, and by mistake you spill your sugar in the sand. How are you going to separate it out? Maybe the thought of that isn't very appealing. Well, the same would apply for salt. What if I had ordinary table salt? And this was important to me, and oops, I spilt it in the sand by mistake. Well, we're not going to be able to see that so well. So I've chosen a different salt. This is copper sulfate. It's another salt. It's blue in color, so we can see it. But imagine all of that spilt in the sand. And I have a mixture like this. Oh dear, how are we going to get it out? Well, you might be thinking it's not even worth it. Well, the mining industry is taking minute amounts of valuable substance that is a mixture, usually with rock, and they crush it up and they separate it. So we're learning to separate mixtures. So how would we separate the sand from the salt? We look at the physical properties of the sand and the salt that are different. In this case, the one dissolves in water and the other one doesn't. So let's transfer all of this mixture into a big container. Now I have a lot of sand and a little salt. It's kind of like what the mining industry is about. Now how am I going to get that salt out? Well, I'm going to take some water. And I'm going to stir it up. And I'm going to stir it for some time until I make sure that all of the salt has dissolved. Now I've got a mixture of salt, copper sulfate, the blue salt, sand, and water. You might say, I've made it worse. It hasn't got any better. Well, you might be able to see over here that the water has started getting a color to it. Now, how can I separate the sand from the water? The water is no longer pure water, it's a solution. It's got the salt dissolved in it. And I'm going to filter it. Well, we won't show the whole process of doing this, because what I'll do is take a piece of filter paper, which is usually round. And if you fold it in half, like that, and fold it in half again, and then you open it up, and you shove it in a funnel, we can filter it. And I'm going to pour the liquid like that. And what you can start seeing coming out of the bottom is a clear liquid. The sand gets to stay behind in the filter paper, and what comes out at the bottom is a liquid, and you might be able to see that it's got a slightly bluish tint to it because of the copper sulfate that's dissolved. I don't know if you can see that against my lab coat. Right. Okay. Now we're not going to wait for this. It'll take a long time. But I will continue off camera, keep filtering this out. Then the question is, well, if I really needed to, I don't want salt water. How do I get the salt out of the water? Again, a different mixture. How are we going to separate the two? Well, the salt has a very high boiling point, very low vapor pressure, and doesn't evaporate at all, whereas the water does evaporate. I could maybe speed that process by boiling it. But alternatively, I can take it and put it in a container like this. It's called a Petri dish. I'm going to stop the process of the filtration there. And I could stick this on the windowsill or just leave it there. It'd probably take a few weeks for all the water to evaporate. But the water will evaporate, and eventually you will be left with the crystals that are there. Oh, it's evaporated. Okay, here we have a mixture of iron filings and sulfur. Imagine that's all nicely mixed up. I've mixed two elements, iron and sulfur. It's not a compound, it's just a mixture. If I had to separate it, how would I do it? Well, we can't go and sort it like we could previously. So what about the sulfur and the iron is different? What are their physical properties that are different? And hid underneath here, I have a magnet. Well, iron is magnetic and sulfur is not. Now, I don't want to just shove that in there, because then I get all the iron filings stuck on here and it's not so easy to get off. So I find it useful to wrap it in a piece of paper. And I'll do this. And have a look at that. Isn't that nice? Take that aside. And now I can just drop it off. I'll put the paper down there again. I'll move it around, and I get all the iron to stick to the magnet. I lift it off the paper. Now, that's not 100% separation yet. There's still a little bit of sulfur, but it's a lot better. So I'd probably repeat the process. Let's try that again. And sometimes separation processes have to happen more than once. And you can see we started off with a messy grey mixture. And the sulfur is nearly completely alone there. There's a little bit of sulfur here, and by the second time, there's even less sulfur. And if I keep going through that process, I will eventually get pure substances. Just now in the lecture, we're going to take this very mixture Let's put them all together again. And this time I'm going to heat them, and we will make a compound which cannot be separated. Right, here we have a distillation setup. In the boiling tube, boiling flask, we have a mixture of alcohol and water. Now they are both polar solvents and they mix, and you can't just separate them. But they do have different boiling points. So if you set it up like this and you heat the boiling flask, the alcohol, which boils at a lower temperature, boils first. And some of the vapor will rise up here and condense this area and run down through the Liebig condenser. Now this is a tube that has two layers. On the outer layer, we've got some cold water running. Now ordinarily this would be attached to a tap, and the water would run in here, through the top and out that side. So I've set up a makeshift reservoir of water, and if I open this little tap, this little clamp, there you can see some of the bubbles running through, and the water is running like that. So this creates a jacket of cold water around the inside of the tube. So any of the vapors coming through this side will condense and run down that tube, and we'll be able to collect a much purer form of alcohol on that side. The other thing to keep an eye on is the thermometer. When it gets to about 70, 72 degrees, then we know that it is the alcohol that is coming off. I'm going to have to keep an eye on that. I can slow it down for now until it starts boiling. And I'll have to top it up now and again. Sometimes if you want a breadth separation, you would extend this column by slipping this interesting tube into it. It's got some interesting little pieces of glass that protrude into the inside of the tube. And that allows the vapors to condense on the side and drip back down. And it means that what is coming through on the other side is much purer. Right, we've got it boiling now, and I don't want that to be too hot, but we should be able to see, if I open this, got the water flowing. It'll take a few minutes, but some of the vapors will not drop back in, but they will actually come down this side. There I can see a drop that's just started to move down. And in a minute or so, you will start seeing drops over here. Now, this is the distillation process that's used in producing all spirits. For example, whiskies and brandies and gin and vodka, spirits, those type of alcoholic beverages. And here we have the first of the distillate coming through. So that would be not 100% pure alcohol, but probably about 90%. Over here, if we can focus in, let's see if we can see what the temperature is. When I come around, I can see that it is at 81 degrees. Now that's a little bit high, a little bit higher than the boiling point of alcohol on its own. So the chances are we are getting some water coming through with the alcohol. So on second thoughts, the percentage is probably a little lower. Whiskey makers, for example, sometimes would distill it once, and they would take the distillate and they would distill it a second time to get a higher percentage of alcohol in the final product. But that is how a typical distillation works. It's used to separate other things. I mentioned before how if we cool air down until we make liquid air, then by allowing the one to boil off first, we can actually separate it That is a form of fractional distillation, and it's also used in the petroleum industry to separate crude oil into its different components. Right, here I have some paraffin and some water. I'm going to make a mixture. It's 2 liquids this time. Put some paraffin in there and put some water. And if I shake it up, you might be able to see it makes what we call this emulsion. Now, how are you going to separate it? Well, from there you can already see it's 2 layers. This apparatus is called a separating funnel. You can see clearly now the 2 layers. And which one's on top? Well, the one that's less dense. Here we have 2 liquids, paraffin and water. They do not mix. They are what we say immiscible. This is a non-polar solvent. This is a polar solvent. Polar, non-polar do not mix. The less dense one floats on top. So the paraffin is what floats on top. Now, once I've put it in the funnel, it's quite easy to collect the separate piece, the fractions. I can open this up, and we can see it running in. And when it gets close to the end, I slow it down a bit, and choop, I turn it off, and there I have now the water. Water is completely separated from the paraffin. If I shake this up a little bit, it looks almost like little droplets are coming down. Those are little droplets of water. I can shake. And often we would put a stopper in the top, shake it like that. We've still got a bit of a mixture at the bottom. So I might even collect a fraction that I don't keep. I might, for example, let's use a smaller container, collect a little bit that catches the water and the paraffin. That is still a bit of a mixture. You might be able to see some of that emulsion there. And then I'm able to now collect my paraffin separately. A separating funnel. Simple and easy to use. Right, we have just seen, it took some time for this to evaporate, but that is how we would separate crystals from a solution. Here is a more dramatic example of it, right here in our hometown in Port Elizabeth, where they pump seawater into these salt pans and allow the water to evaporate. And there you can see a big mound of salt. This particular company is Mariner Salt. We also looked at distillation, and how that works. And then how a separating funnel can be used to separate immiscible liquids, liquids that do not mix and also have different density. The paraffin was a non-polar solvent and floats on top of the water because it's less dense, the water, than the water, which is a polar solvent.